Well, hello Internet, and welcome to my Perl 6 video tutorial. This one tutorial is a $40, 400-page book condensed into one video. In the description, you will find a cheat sheet, transcript, as well as a clickable table of contents, and I have a lot to do, so let's get into it. Now, the easiest way to install Perl 6 is just to go to this URL in the cheat sheet that I have in the description. You can find that link, or you can pause your screen, and basically, if you want to install on Windows, I would use Chocolatey, and if you want to use Mac OS, I would use Homebrew. Of course, all you need to do is run those commands inside of your terminal, and you will be ready to use Perl 6. Now, on the left side of the screen, you will see the Atom IDE, and over here I have either the terminal or command line if you are on Windows, and as per packages, it's all free stuff, by the way. As per packages, if you just go to packages and command palette, toggle, and install, and then come down here to view installed packages. If you're installing, you're going to use this guy instead, but I just want to show you what I have, and you can see language-Perl 6 is what I installed. All right, and after you do all that, you are ready to go. Now, basically, comments are just going to be hash symbol, so there's a comment, and then if you want to do a multi-line comment, you're going to put a hash symbol, and then this little quote like this, and then this is a multi-line comment that is self-terminating whenever you have this bracket right here. So there you go. Comments are out of the way. Now let's do a simple hello world, and there's multiple different ways to output to the screen, which I will of course cover, and we're just going to come in here and go hello world, and the name of this file is perl6tut.p6, and then over in your terminal or your command line, you're going to run that command right there, and that is going to be your output. Now what I want to do is show how to receive user input, and whenever you are creating your variables, which are going to store values, you're going to type my, and then you're going to have this sigil right here, which is going to be a $sign. You're going to be other ones I'm going to cover later. And if you want to get user input, you're just going to type in a prompt, and then you could say something like, what's your name? Always end your commands with a semicolon. What this is going to do is ask that command right there, and then store the results the user types in the variable called name. Then what we can do is just go and output it, and we can just go hello, and directly inside of here you can put your variable, and it's going to work. So then we come over here, run your command, you can type in Derek, and you will get hello Derek. All right, simple stuff. Now one thing that comes up a lot is the differences between say and put. And basically, say normally provides the same output as put, but sometimes put is abbreviated, and let me give you an example of that. So this is a range, which we will talk about later on, and just a range of values, and here we go. So there is an example, and if we go and we run that, you're going to see the difference. Basically, you get an abbreviated version with say versus you get this long list of numbers, and in some situations one's useful, and in other situations others are useful. And another command is print, and basically the way print is going to work is whenever you use it, it is not automatically going to provide you with a new line. All right, so there we are, and you can see that it messed that up. All right, so there's some simple stuff. Now I want to talk about variables. Now your variable names are going to start with a letter number and can contain underscores, hyphens, and apostrophes. And I talked about mutable, which means changeable, meaning you can change the value of a variable previously. And there is also the option to make immutable or unchangeable values, which means basically once you set the value, it is set forever. So let's come in here and let's go pi. So there is a value that cannot be changed. Now, if we would come in here and try to change said value, you would get an error. So let's just say we want to make it 4, come over here, cannot modify an immutable capture. All right, so you can see how that works. And that was done just by changing that sigil. Now you're going to be able to define multiple different types, and the common types are going to be bools, ints, nums, which are floats, real, which are going to be non-complex numbers, strings, and dates, and we will cover all of those in examples as we continue. Once again, we can come in, and you're also going to be able to actually define those types if you would like. And how you would define those types is just by typing in their name. If you haven't noticed, I move very quickly, so be prepared to always hit the pause button in these tutorials. So here I basically said that I want this always to be an integer, so that means if I come in and try to set it to a non-integer value, that is going to give me an error. And you can see right there that it did indeed give me one. However, if I come in and let's go y is equal to 6, and I do not define a type, and then I come in and say that I now all of a sudden want y to be dog, that is going to be perfectly fine, and it's not going to give me an error. Another interesting thing is the binding operator is actually going to create an alias to a variable, and how you use it is you go my like this, and z, and like that. Let's bind it to the variable y, and what that's going to do for us now is whenever one value changes, it's going to change for both of them. As you can see, it did right there. Boolean values are going to either be true or false, and 0 is normally considered to be false, and everything else is considered to be true. And we can define one just by going my bool and can vote equal to true. And if we say we want to see that on the screen, you can see the true bounces back, of course. You're going to be able to use exponential notation as well. So let's come in and let's just define 1000 equal to 1e3. That's something that's possible. You're also going to be able to show the types of your variables. So let's come in here, go with 10. You could go 10 dot and then name like this. And I threw a couple more inside of there. If you would want to actually surround this 10 with double quotes, you just need to escape it. So that's a quite simple thing to do. And whenever we run that, you're going to see all of the different data types: integer, rational, strings, and so forth. Now let's talk about some casting and conversions. Well, you can come in here and convert an int as a Unicode into a character. So let's go 65 like that, and then say that we want to change it into a character. Let's do more. Let's come in and convert numbers to strings. So I'm going to say type, and then go 10 and str. That's a capital STR. And then let's come in here and verify the type, which would be useful. And make sure you type in say instead of Saturday. I'm thinking about Saturday right now. You convert strings into numbers. Once again, we'll go and do type. And you're going to have to put a plus sign inside of here. And then 1, 2, 3, whatever you'd like to convert. And then let's go and get the type for that as well. And also auto casting is going to work. And let me give you an example of that. So we can go like this. And then we could throw in a string, but then we could go and add 2 to it and see how that works. And if we run it, you can see that all of the conversions worked exactly as we proposed. All right, so there's some quick rundown of some variables and data types. Now I want to talk about math. Now you're going to be able to use many common math functions, and I just want to show you another different way to output your or format your output. So let's say we have 5 plus 4, and you want to format that. Just go fmt, and then you can go and inside of quotes go 5 plus 4 is equal to, and you're going to put a % and d if you want to work with decimals, which are going to be integers, values without decimal places. You're also, of course, going to use a % and f for floats, which are numbers with decimal places, and a % and s for if you want to work with strings. And here's a couple more little guys we can work with, and let's go and do some more after that. Let's do some working with formatting of floats. We can come in and say 5 divided by 4, for example, and then format that. And then we're going to put a % sign, and let's say we only want to show 2 decimal places. We'll put 0.2 inside of there, followed with an f or the float. And why don't we throw another one inside of here? Let's go that to get this power right here, and then let's change this to d. And if we come over and run it, you can see that we get what we would expect. Let's do some more. Let's say we want to add fractions. You can do that. So you can do something like 1/4 and 1/2, 1/4 and 1/2, and format. Then inside of here, put the fractions inside of there, and everything's just gonna work. You don't have to think about it. Once again, let's say we want 2 decimal places for this guy. Run it, and you can see that it works. Another thing is, let's say we want to generate a random number between 0 and 20. All we would do is say what our max value is going to be. It's going to use 0 by default. But let's say we wanted to get and use more specific ranges. And to do that, what we're going to do is put a range inside of here, 5.20, and then apply random to that. And then the int part here is just making sure that it comes back as an integer. And there you can see we got that as well. And if we go and run it again, you can see that we got different values, and we can do this forever and get different values every single time. time, hence the term random. Now, using the base floats inside of Perl, you can see I just threw in some great big giant huge numbers. You can basically expect about 15 digits of precision by default, and if we run it, you can see that it fouls up right around here, and most programming languages do that as well. Another thing is, let's say I want to come in here and do or work with a couple other different math functions. You're going to be able to do things like putting the function name with the parentheses like we saw previously, or we can have the actual attribute, which is what we have right here, where we have the attribute first and then the function, and it is still going to work. And I can demonstrate how that works just by coming in and getting the absolute value of this guy, and throw a couple more of these guys inside of here just so you can see the demonstration. And there you can see it works either way, and that means that we either put the attribute first followed by the function, or we go and use the more traditional way. I then went and threw in a whole bunch of other built-in functions just so you could see them on your screen here all at one time, and you can pause your screen or you can get the cheat sheet, and if we want to run all of them, there you can see the results for every one of those functions. Alright, so there is a quick rundown of a bunch of math functions and a bunch of things you can do with math and using Perl 6, and now I want to talk about conditionals. Now you have the common conditional operators being greater than, less than, greater than or equal to, less than or equal to, and not. And then you have the logical operators and, or, and not, or not. Okay, you can actually type all those out. Now I'm going to give you some examples. So I'm going to come in here and I'm going to say my age is equal to 12. Then I'm going to perform different actions depending upon different conditions. So I'm going to say if age is greater than or equal to 5, and you don't have to surround everything with parentheses. Perl 6 is smart enough to figure out what you're trying to do. And less than or equal to 6, you're then going to put your curly brackets, and you always want to make sure you put a space between the last thing and the curly brackets, otherwise you will get an error. And I can say go to kindergarten. Now let's say you want to have another condition embedded inside of here. You're going to go else if, like that, get rid of that E. You can also use a shortcut chain comparison where you go 7 less than or equal to age less than or equal to 13. I don't often use it, but some people like it, so there it is. And in that situation, we're going to say that they have to go to middle school. Once again, we can use else if. Here I'm going to go back to the more traditional way of doing comparisons, and then we could send the person to high school in that situation. And then as our final condition, we would throw in else, and in that situation, we would just tell the person to stay home. And if we run it, you can see that go to middle school comes back as our result. We could also come in and say that we want to execute things only if they are true. So we'll say old enough for school, and then follow that up with our condition at the end of it. If age is greater than or equal to 5. And you can see that it goes and does that because the condition is true. We're also going to be able to come in and execute if a condition is false by using unless. So let's go and create another variable here. So we'll say unless k is equal to 5, put x or put k. There's also the ternary operator, which is going to return one value or another value based off of a condition. So we'll say can vote and the condition, and if it's greater than or equal to 18, then you're going to put question marks, and true will be returned if the result of this condition is true. Of course, it doesn't have to be true. It could return 1 or 5 or 1 million, do whatever you want, and otherwise it will return false as a condition. And if we run it, you can see the results of that code. All right, so there's a quick rundown on conditionals. Of course, we'll do more as we continue. Now I want to talk about strings. Now you of course create strings like you create just about anything. You can, let's go and create string 1 is equal to hello. Like we showed previously, you're going to be able to use your variables directly inside of your strings without any problem at all. You're going to be able to escape multiple different things like new lines and tabs, carriage returns, and alarms, and all kinds of other different things, as well as quotes, as we saw. Let's do that again, just in case you jumped here. We can say I like and quotes. always make sure you put the semicolon at the end of the command. You can go and get the number of characters inside of your string just by typing in characters at the end of it. You can find out if it has a value just by putting a question mark and then whatever you want to actually check. You're also going to be able to use protected characters by surrounding the output with Q and different delimiters. So you're going to put Q, and this is your delimiter, and then you can go str1 is okay here, and then end that with your delimiter. Let's go and run that, and you can see all of the results of our code. You can also see right here that we were able to print that variable out instead of that variable name instead of the value itself. And you're also going to see that you're going to get the same results if you use single quotes. So we can say like that, throw that inside of there, throw that there, and do this. And basically the double quotes are going to change the variable's name into its actual value, while the single quotes will not. You're going to be able to concatenate or join strings. So we can say one, and then you're going to throw a tilde inside of there, and string. You're also going to be able to use join for that. So let's create a new string inside of here. And what join does is it's going to actually take this space and put it in between every string that follows after it. So we can say a long string, and it's going to put spaces between every one of those. And let's go and output that. And there you can see spaces. You're going to be able to have multi-line strings. So we can say, let's go and create another string here, equal to, and you're going to put Q inside of here, space, and then here doc. And then you're going to define what will end this multi-line string, which is going to be the word end. And we can go, I go lines like that, and then type in end, and that is going to end your string. And you can see that it goes and keeps that multi-line string exactly as you inputted it. Now let's start doing some functions here. Let's say we want to find out if a string contains another string. So we can say long, and then the string that we want to analyze, and that would be using the function contains, and then what we were specifically looking for. You could also come in here and grab this guy, and if you wanted to have the search be case insensitive, you're going to follow this up with FC, and you can see it comes back as true both times. Of course, if you find a match, it might be useful to get to the index where you have the match. So just have that be string index is equal to str2, and you would type in index and then whatever you were specifically searching for. You would be able to grab substrings by using the index. So we could say str2 substring, and then if we know we have a match, we could come in here and go s, and that's going to be our index, and then let's say we want to get the next 5 characters to come after that, and you can see that it went and grabbed long out of the longer string. Going to be able to trim white space in multiple different ways. You're going to be able to trim the leading like that, or you can come in and trim off of the ends of your string like that, or you can do what I do and just get rid of both of them at the same time. So I can say by white space, and then go and throw a whole bunch of white space inside of there and some trailing space, and then end that with trim, and that will get rid of those additional spaces. We're going to be able to convert to lowercase, uppercase, and title case. Title case is just the first thing is going to be uppercase, the first character. So there's lowercase, and then we can do ABC, and this will be uppercase, and then we will have the title case, and that's TCLC. And let's do the ABC again. And there you can see how those work. We got more. We're just getting started. We're going to be able to come in here and check for equality between strings. So let's throw dog inside of here, and let's convert it to a lowercase, and then check equality with dog, and that will come back true. We could also come in and let's do a comparison for greater than, and basically greater than is based on alphabetical order, and uppercase is going to be greater than lowercase. And to show you an example, we could go ABC greater than, and then throw in D. You can also come in and remove the last character just by using chop. And you can see that I don't have the parentheses inside of here like this with all the functions. You can just go and abbreviate it and it works fine. You'd be able to use or eliminate a new line with chomp, right like that. You would be able to use variables without spaces, as you will see right there. If we put curly brackets around this, and there's Derek, you can actually do code inside of your strings. So we go 5 times 4 is equal to, and then go and do the actual formula directly inside of the quotes. You can use interpolation only between braces by coming in and going Q, C, and then we'll go new line 1 plus 2 is equal to, and 1 plus 2. You're going to be able to get characters using their Unicode. So right like this, X and 40. You would be able to duplicate strings. So we'll say str1, and let's say we want that to be output 5 times. That's going to do that for us. And let's go and run these. And look at all that stuff. And see, multiple times. And there's the Unicode. You can see exactly how we're able to output all this different information in multiple different ways. Do a little bit more complicated stuff. Let's say that you wanted to split based on a delimiter. So we just go split, and we're going to say that we want to use a comma followed by a space to do our split, and then we go and put our input. So you can see there's the comma and the space, comma and the space, and C. We're also going to be able to use split using regular expressions, and I will do a lot more with regular expressions later on, but I just wanted to give you an example right here. So we can go split, and then we can say that we want to split based off of multiple different things. So we could put a semicolon inside of here and a comma, and then close that off. And like I said, I'll do much more with regular expressions later on. And then we can throw in multiple different things, and as long as one of them matches, we will get a match. And let's say we wanted to do a split using another regular expression. Throw A, B, and C inside of here, and we can do a split and say we want to split where there is white space. That's the regular expression for that. And for the final example, let's say that we want to replace matches. String 5 is equal to Derek is terrible, and we can't let that stay, so instead we're going to go put and str5 substitute, and then what we want to substitute, which is going to be terrible with awesome. No, I don't think I'm awesome. I just being goofy. And what did I do? Oh, I did something wrong here. Oh, I see what I did. I need to surround these with brackets. That, and now it should work, and there you can see that it did. All right, so there's a quick rundown of strings and a bazillion different commands you can use with them, and now I want to talk about looping. Okay, so basically looping is going to execute as long as a condition is true, and there's a bunch of different ways. I'm going to show you a whole bunch. So what we're going to do is we are going to create our value that is going to increment, and then we're going to define our condition, which means it's going to continue looping as long as I is less than 20, and then we are going to say that we want to increment I every time. Now let's say that we only want to output if a value is even. How we do that is we go and get our value, we put modulus inside of here too, and in the situation in which you get a remainder of 0, modulus gives you the remainder of a division. In that situation, we're going to say that we want to output that value. Now let's say that you would now want to stop executing code inside of this loop and start over. You're going to come in and type in next, which is like continue in other programming languages. Then let's say we want to artificially stop our program if I is ever greater than or equal to 10. In that situation, you would type in last, which is like break in other programming languages. And if we execute it, you can see we got our even values just like we thought we would. Let's do another example. Let's come in and just do a loop on its own. Then I'm going to mark a variable with state, and marking this as state basically sets the value only one time, no matter how many times we would loop. So you can go and initialize variables inside of the loop, which is quite useful. Then what I want to do is I want to output the value for j and then increment the value. And then I'm going to say that I want to leave if the value for j is ever equal to 5. So there there's a more simplified way of coming in here and handling looping and exiting instead of typing out all of that stuff. There's also while loops. So we can do basically a while loop. You need to initialize outside of it. Let's go. I1 is equal to 0, and it's going to execute as long as the condition is true. So we'll say 5 like that, and then put and I1 and increment that value as well. And you can see that worked as well. Other looping options, we could use repeat, and the repeat while is going to execute once and then check the condition. So it's like do while. So we're going to say repeat while I1 is less than 5 and go and output and increment just like we did before. So the repeat while is like a do while loop. Let's go and do another example. Let's go loop, and I'm going to do state again and initialize it. And it initializes one time, remember? And then we can go and output and then increment. Then we will say that we want to jump out of this loop or finish looping if the value for k is greater than or equal to 5. And then a thing called a phaser is going to run at the beginning as well as the end of a loop. And this is going to be what happens whenever the loop first starts running. So you could say something like starting, and then for the last part, after the loop is done, you type in last, and then whatever you want to have happen. You can have multiple things happen inside of here as well, inside of the curly brackets. And if we do that, you can see that starting pops up right here. It does the loop stuff, and then ending shows up right there. All right, so multiple different ways we can use looping, and we will do more with them whenever we talk about arrays in a little bit. Now I want to talk about blocks. Now you're going to be able to store blocks of code in a couple different ways. This is an interesting way. So what we're going to call this say hello, and then a colon is equal to, and then it is going to say, or it's going to execute out hello followed by a $sign and an underscore, and that is going to represent an unnamed passed parameter to this block for execution. Now what I can do is go say hello, and I can throw in my name, and my computer will talk to me, and there you can see it did. But you can do way more interesting things than that. Let's say we wanted to use multiple parameters. We could come in and say add nums, and again colon equal to, and then whatever we want to do inside of here, and we can go and use multiple different values. We can say a plus b, and then go and call for its execution and pass in our two values. And you can see it added. You can use things called thunks, which are star symbols, to create closures, or whatever codes is what they're often referred to inside of Perl 6, and I'll give you an example of what that looks like. So there is a thunk plus 2. Now we can come in and say plus 2 and throw in 5, and you can see that it added 2 to that value. You're going to be able to use things called subsets to create data types that can, let's say we want to hold only even values, for example. So we're going to say subset, and we'll go even int of, so it's going to be an integer where, and this guy will only hold even values, and we'll go and use modulus again. 2 is equal to, and this is the condition that we are setting. Now what I can do is go my even int eval equal to 4 and say even value, and of course it outputs that. However, let's change it to 5, and you can see that it gave me an error. So that's a way of creating custom data types that have restrictions based off of a condition that you define. Told you I was covering everything with Perl 6, and I am. All right, so there's some interesting things you can do with blocks. We're going to do more later on. Now I want to talk about lists and arrays. Okay, so a list is a immutable series of values, which means values can't be changed. And let's go and create one here. So list, and follow that up with new, and then you can go and throw in all of the different values that you would like assigned to that. Now instead, if you want to create an array, you would come in and go and put an @ symbol like that, and let's go list2 is equal to, and then 1 and 2 and 3, and that is going to create an array in which the values can be changed. You can get the number of values out of these guys just by going elements like that, and anything that works with a list is normally going to also work with an array. Just make sure you put the @ symbol in there instead of of the $sign. You're going to also be able to create a list with values separated just by spaces. So we can come in and go 3 is equal to, and then we can just go Mark, Sally. You don't need to use your quotes or any of that stuff. Close that off at the end and then get the number of values out of there. You can get the value by using an index. Again, you can do this with both lists as well as arrays. Don't want to do it for everything twice. You can get ranges of values as well. And let's say we want to get to the first 2. There you go. You're of course going to be able to change values just by referencing an index. Let's say we want to change that to Pam. You would be able to shift off the first array element, which is going to actually output it, but at the same time delete it from the array or list just by going shift. You would also be able to shift a new value onto the front by going unshift. And then let's go and throw these in here again without using our quotes. And we could pop off the last value just by using pop. Again, it's going to output it, but it's going to delete it from the last part of it. And we would also be able to come in and push on a value to the end. So as long as you are not changing the list in any way, you would be able to use anything with lists that you can use with arrays and Okay, whoops, got something wrong. You can see right here in the error message, see it has my actual file and it says 1, 2. So I know I have the error on line 12, and I forgot to put an equal sign inside of there. And there you can see how we were able to output that information. I have many more examples. Let's say we wanted to splice off values by index. So once again, come in and go splice and 0 and 2. Throw a new line in there just so we can see where we changed our code. You can come in and search for a match. So let's say we're looking for Pam at L3 and grep and then Pam. We can filter lists. So we can come in and say that we only want even values, and we'll throw a range inside of here, 1 through 10. Again, more on ranges later on. And then we can come in and get each individual value. So if we don't have a specific name, we just use the $sign and underscore and then 2. Run that and you can see those values and how they work. We can also cycle through lists using for. So I didn't cover for before, but thought it would work better by actually covering it here. We can go and this guy, by the way, is known as the topic variable. You can also get multiple different values using the for loop as we cycle through. So let's just throw that there. And how you do that is a dash, make a little arrow there, and then say where you want those values to be stored temporarily. Also, make sure you always put a space there. And then we can go X and Y. You can get keys as well as the index. Let's just throw that in there again. Follow that up with KV and then little arrow and index, and let's call this item. And then inside of here, we can say index and the index, and then item and the item value. Whoops, got an error. Forgot to put the dot inside of there. And there you can see we were able to get all those guys. We're going to be able to sort our lists just by going sort and whatever list you want to sort. You can create lists of lists or multi-dimensional lists just by coming in here like this. And then we can do something like 1 and 2, close that off, and 3 and 4. We'd then be able to get those based off of our index. So let's say we wanted to get whatever's in the 0, 0 position. We can, of course, and how we get it, it just got 0, and then we could cycle through. I'm sure for homework you can figure out how to go and loop through multi-dimensional lists. I'm sure you can handle that. You can combine multiple lists into one by using zip, and I'm just going to come in and do A and B like that. Whoops, and 1 and 2 like that. So zip combines lists. You also will be able to declare 2 variables at one time by referencing a list by just going my and then throw this inside of here, value 2 and value 3 equal to, and then whatever is contained inside of our list. You're going to be able to store variables in lists without using commas. just by coming in, putting in 2 of those little brackets and closing that off. We're able to output with delimiters. I think I covered that once before, but I just want to cover it again because I can't remember if I did. And you can just say that everything needs to have a comma and a space between it. And there you can see all of that output that we have. We're also going to be able to come in and turn a string into an array. So let's come in and go string 4 is equal to A, B, C, and D. And then do it again. So we'll go and create the list here is equal to and str4 by using words. That's what we use to turn a string into an array. And we can output that. We're going to be able to reverse lists just by using reverse. And for our last 2 examples, I'm going to do something really cool. I'm going to use a map to transform each element inside of our list here, or our array. So we'll go L7 is equal to 1, 2, and 3. And then I'm going to say my, and I'll call this map1, and here is the map. And here what I'm doing is saying that I want to cycle through that, and I want to multiply every single thing times 2. And the thing I'm going to cycle through is going to be our array that we just defined. And then we can output that onto our screen and do another one where we're able to add 2 lists. So let's go and create yet another list equal to 4, 5, and 6, and then output that and add them together. And this guy is called a hyper operator. And what I'm doing here is I am going to add these values, but you'd also be able to multiply, divide, do whatever you would want with every single item inside of our list. Both lists, actually. And there you can see how those work. All right, so quick rundown of numerous things we can do with lists and array. And up next, I want to talk about ranges. All right, so I did a whole bunch with ranges already. Basically, you can create ranges of values as long as they are in order, meaning 1, 2, 3, or A, B, C, or whatever. It's also important to know that ranges are not lists because they are called ranges. All right, so here is a range, and you've seen them before, and there you are. So that's going to create a range of values 1 through 5, incrementing by 1 each time. Now you are able to turn a range into a list, however. So this will be a range list just by coming in and go and referencing your range and then following that up with the list. And you would be able to come in here and exclude lefts and rightmost values just by coming in and doing something like range 2 is equal to 1. And if you want to exclude what is on the left side, you just go like that and like that. And if you want to exclude what is on the right side, let's go and create another range equal to, and then we can say 1 dot dot 5 like that. All right, so we're going to be doing more with ranges. I just wanted to cover a couple things that, I hadn't covered with them yet. And now I want to talk about sequences. Okay, so sequences are lists that defer the creation of values, and those values are not going to be stored. And they're best understood just by covering a whole bunch of examples. So let's go and create sequence 1 and like this, and then you can define your gigantic sequence of values. Now, sequences also can count down. So let's go and create yet another sequence, and you can see the colon equal to, and let's follow that up with 10, 1, 2, 3. There's 3 dots instead of 2, which you have with ranges. And something, interesting you can do is, let's say that we would want to create a sequence using an algorithm, such as a Fibonacci series, which is 1 and 2 and then 3. See, as we add these up, so this plus this makes that value, this plus this equals that value. How would we do that? Well, I'm going to show you. So I'm going to come in and I'm going to go my fib, and I'm going to say equal to, of course, that I want to start with a 0 and 1, and then I want to define what happens afterwards. And this is really cool stuff. So I'm going to say that I want to get those values and throw that inside of there. So the first 2 values that were already entered, and then to form the next value inside of this sequence, I want to add those values, and that is going to create the next one. And then what I can do is 1, 2, 3, and star and 1 like that. Now I can come in and just go put and fib and 10 and go and join all of these different values using a comma and a space. And whenever I do, whoops, I accidentally typed in a 1 and a comma and a semicolon at the end. Let's throw that in there. And now I can go like this, and it's automatically going to give me 10 values that match that inside of that sequence. So super cool stuff. Another thing that is interesting is you can check for what is called a lazy list. And that just means that the calculation isn't done until the user says that it wants it to be done and those values are not stored. And I can do that just by going and getting fib and asking, is it lazy or not? And it will tell you if it's lazy or not, and it comes back as true. Okay, quick example, super awesome example using sequences. Now I want to briefly talk about sets and maps. And basically a set is just a list that does not have duplicates. So let's come in and my set is equal to set, and then let's say you try to throw duplicates inside of it. There you are. Then you would say and my set like that, and you're going to see that the double 3 disappeared. All right, nothing that complicated about sets other than that. Now let's talk about maps, which are basically immutable lists of key valued pairs. So let's come in, I'm going to say my Japanese family, and so here is a whole bunch of different things. So this is going to be our key. I'm going to say that that's going to be dad, and then I can come in and throw in the translation, Otosan. If I pronounced that wrong, I'm sorry. And then we can do this for all of the other different family members, and then end that with a semicolon. Once again, here is the key, here is the value. Now we would be able to come in here and get the value just by using our key. So dad like that. We can go and check if the key exists, my Japanese family, and throw in mom inside of there, followed by exists, and that's going to give us an answer. And if we're cycling through, we could get keys and values, my Japanese family, and keys and values, a little arrow symbol, and the variables we want to store them in, and then go and output those on the screen. Key and the item value. Whoops, and I forgot to put a colon inside of here where the exists is. So there it is, and if we run it, you're going to see that those work. Okay, so quick rundown of some things you can do with maps, and now I want to talk about hashes. All right, so basically a hash is a mutable map. So let's come in and let's create one. Japanese color. Mutable just means we can change the value. So we'll go hash and new, and I can come in here and do something like blue and ao and red and aka and green and midori. Okay, now I would be able to come in and change the value. If you noticed, which I doubt you did, that I actually put in the wrong value for blue, just like that. All right, so there we have that changed. We can also go in and delete key values, Japanese color, and let's say we want to delete blue altogether just by typing in delete. We can add key values, so that, and let's say we want to put white inside of here, Shiro, and we can get key valued pairs by looping again, by typing in key value, little arrow symbol, followed by key and item, and key and item. There we go. And you can see that it worked. All right, so another example using hashes. And now what I want to talk about is subroutines or functions. All right, so with subroutines, we're going to be able to return values. And basically the way you create a subroutine, a function, whatever you want to call it, is you're going to have sub, whatever its name is, and then your arguments are going to be between your brackets. And you can either have the data type defined or not defined. So let's create one. Call this add nums2, and let's go and you can go and give default values if you'd like I just did right there. So default values of 1 and 1 for both of those, and then of course you can just return those values afterwards. So just reference them like that, and there we go. And then we can go and use them just by going in and saying something like 1 plus 3 is equal to, and follow that up with add nums. nums2, and then throw in your 2 arguments. And if we run it, you can see that it works. Okay, so let's do more complicated ones. Arguments can also be optional. So I'm going to say give me, and I'm going to go arg and throw a question mark inside of there. And then you can say return arg, and then say give me, just by going calling that and not throwing anything inside of it. And then in the next one we can throw it something like this, and there you can see any came back and 1 came back whenever we actually provided a value. You're also going to be able to store functions in a variable, so we'll go and basically have to put an and sign inside of there, and then sub1 is equal to and add nums2, and then you'd be able to come in and go and reference that just by sub1 and 1 and 3 once again, and you can see that it gave the result 2 times. You can use something else called the Slurpee parameter, which is used to accept an unknown number of arguments. So we'll say sub add nums and 3, and here it is. It's a star symbol, and you go star at and nums. Then I'm going to come in and say state and sum is equal to 0. Remember that by putting state inside of there, that it is only ever going to be initialized with that 0 value 1 time. And then we can go nums and pull each of those out separately, and they will be assigned to the variable num, and then you can go and add those to sum, right like that. And then after you go through that loop, you can return sum, and you'll be able to throw in as many different values as you would like. Nums 3, and then it doesn't matter. And also you can get rid of the parentheses altogether, so just another thing you can do if you'd like. Whoops, got an error there. That's because I put 2 there instead of nums. See, I want to get this guy and put that down there. And I forgot to put the S up here. Whoops. All right. And I must have accidentally forgot to put the closing bracket inside there. And there you can see that we were able to get our sum. You're also going to be able to return multiple values. So let's do that. Go sub, and let's call this next 2. It's going to receive a value, and then it's going to return the next 2, like we're going to increment them multiple times. So we'll say return, and it'll just be a plus 1, and then a plus 2. I know it's a goofy thing, but I'm just looking for an excuse to do it quick. So next 2, change that to 2, and then throw 1 inside of there, and you get both of those values. Also, you're going to be able to pass a function as a value. So for example, if I wanted to square values in a list, I could do something like sub square, and there's the attribute, and it is going to basically just go and multiply values times each other. And now I have that set up, and I'm going to say my create a array squared list is equal to, and we can use map and square, and then we could throw in a range of values if we'd like to square all those. And then we can come in and say join them and separate them with a comma, and squared list, and make sure I spell square right, and there we go. We went and generated that. Another thing is recursion is whenever a function calls itself, and basically I'm going to use it to calculate a factorial, which is a common thing we use in these examples. So it's going to receive a value, and the only thing with recursion is at some point you're going to have a condition in which the function is not called again, and this is that said condition. And whenever it gets a value of 1, it's going to return a value of 1. Then we're going to say else, and come down here, and this is where we're going to return the value calling the function again, which is factorial, and then pass in a value of a, and you can see there a is eventually going to have a value of 1. Now what we can do is run it, and you'll see how the factorial works just by saying say factorial and then pass a value of 4 inside of there, and there you can see the factorial is 24. And if you're wondering how that works, basically whenever we pass 4 inside of it, you're going to get a value of 3 right here. That 3 is then going to go down here, it's going to be decremented to 2, that 2 is going to come down here, it's going to get a value of 1, then we're going to have 2 times 1 is equal to 2, that 2 comes up here, get a value of 6, that 6 comes up here, and you get your final result of 24. And there is a rundown of functions and subroutines, a whole bunch of things you can do with those. Now I want to talk about exception handling. Now, exception handling is whenever we set up our code to catch errors, and what you want to do is surround problematic code with a try block. So what I'm going to do here is do a divide by 0 error. So I'm going to go answer is equal to and 10 0. You can also throw your own exceptions. So I could say something like die and bad stuff is the error message that I would be passing whenever that would go. And then what you're going to do is you want to list all of the exceptions that you can catch. So I'm going to say catch and then list them. So I'm going to say when we get a error, numeric divide by 0, and you can get a whole giant list of all the possible exceptions if you search that up. So I'll say error, and if I want to list a specific error, I just go the dollar and the underscore like we've done previously. And if you want to catch all exceptions, you could just throw in default, and then you could say, I don't know, default error, whatever you'd want to say, and underscore, and you can see attempt to divide by 10 by 0, and then you can see the error that we have here. And then if I come in here and just comment that out, it doesn't matter what I did, and run it this time, you're going to see that bad stuff came up because I threw that error itself. Okay, quick rundown of exception handling. Now I want to talk about file I/O. All right, so I'm going to show you how to create a file that we're going to write to. So I'm just going to call it F1, and how you do that is you say open, and then this would be whatever the file names is. So I'm just going to call this my data, and then I'm going to say here that I want to write to the file. That's what that means. Now if I want to write text to the file, I just come in and say print, and I can just say something like file stuff and then throw in a new line at the end of that, and that will print any of that text to the file. I can also come in here and put in variables if I would like. So I'm just going to say like this, and print, and my name is, and throw in string and a new line, and then follow that up with my name. And of course I need to create that variable, so copy it. My name is equal to, and whatever you'd like to put inside of there. If you want to put Derek, that's fine. And then after you do that, you could close your file, and there you're done with that. Now another way to go and open, write, and then close the file all at one time is to use Spurt. And again, you can just go and list your file that you want to write to, and then you're going to say, let's go spurts stuff. That's what you're going to write to your file. And if I want to append, I just go append at the end of it. And if I don't want to append and I want to overwrite, I just get rid of that part right there that was highlighted. So that opens, writes, and then closes the file. Now if I want to read from the file, let's go file2 is equal to open my data, and I just put inside of here that I want to read from the file by doing that. Whoops, by doing that, and now I can read from it. So I'm going to say my data is equal to, and I'm going to slurp out the information. So F2 and slurp, and then I'll be able to output it, manipulate it in any way that I would like to. My data, and then at the end of it, of course, you want to close your file. All right, so that's pretty much all the things. And there you can see it went and printed out all that stuff that was in our file. So pretty neat stuff. And now I want to talk about file manipulation. All right, so let's say I want to come in and I want to check if the file exists. I can say if my data .io.e. I'm going to check for the existence of the file. I'm going to say that I want to print out exists. And there that is. Let's do more. I can also find out when a file was edited. So just say my data, and of course you could just save this name IOE into a file if you'd like, but I'm just typing it this way. IO and modified, and I want to convert it to something that makes sense. Otherwise it'll give you like the number of seconds since 1970 or something like that. So there's that, and do a couple more of these. Let's say I wanted to find out when it was last accessed. I can go accessed date time, and let's say that I wanted to get the size of it. That would be IO and then just S in the number of bytes. You're also, let's go and run it. There you see all that information. Let's say that I wanted to rename a file. I could do that. Rename my data to my data 2, put quotes around it, my data 2. I could copy a file, so my data 2 and copy it. Let's say I wanted to do a backup. There's a backup of my data. I could make a directory. I can do tons of shell commands and things, which I'll show you a little bit of, but I'm not going to turn this into a Unix or Linux tutorial. I have a shell scripting tutorial that covers all the different shell commands. If you want to watch that, you can watch that and then do it with Perl if you'd like. I can check if a directory exists. So Perl stuff, and then follow that up with io.d for directory. I can get a directory listing. So there's the directory listing. I could remove a empty directory. Has to be empty. Perl stuff, which is what I just created, or die, and then question mark, exclamation mark. And like I said, you can run shell commands. Here, I'll run a couple of them just to show you that you can do it. So LSL, shell scripting tutorial is what you want to see if you want to see a bazillion of these. And shell op is equal to, and you're going to do, if you wanted to actually store the result of a command, you could do so. And then you just list in the commands you want to have. Oops, make sure you put a space there. And there's all that stuff. And there you can see as I run through every single thing there that I just did. All right, so a quick rundown of different ways you can manipulate your file system and run commands and do all kinds of other stuff. Now I want to show you how to use a module to grab data from the web. Now you could go to modules.perl6.org. There's a whole bunch of different things here, and there are a bunch of pre-made functions that do all kinds of cool things. If you want to check those out, I'm just going to give you one example. Now, if you installed everything the way that I asked you to, you can use a thing called ZEF to install modules, and the modules, that I showed you previously. You could install the most popular by going Zef and install task and popular. That would be a command you could use to install. Or I'm going to install a agent that's going to allow me to pull data from a website. And how you do that is you go Zef install HTTP and user agent. I already have it, but you can see how it works, and there we go. All right, so that's how you would do that. And now I'm going to show you how to use it. So basically, to any module you want to use that's installed, you just go use HTTP and user agent, and there you go. Now you can use it, and I'm going to go and grab some data from the web just to demonstrate how you would pull data from the internet using this. So HTTP and user agent dot new. Now I need to define my wait time before I time out trying to get a hold of this information. So go user agent time out, and I'll go put 10 inside of there. Then I need to get my URL, and I just got a random book off of the Project Gutenberg website. So there it is if you want to pause your screen and write it in, but it doesn't really matter. Can pull data from anywhere. Then I want to see if I can get my data, so I need to do a response equal to user agent dot get and URL. Then I wanted to actually get my data, so I'm going to define there's my data where I'm going to store it, and then I'm either going to be able to get the data, or Project Gutenberg is down right now, it will fail. So to do that, I go is success, which means I was able to get my data. In that situation, I want to store that information, and I should put this inside of exception handling code, but I'm not going to. So I'm just going to go response and content. There's homework for you if you'd like to give that a try. And otherwise, I'm going to say else die and response status line. All right, and there it is. Okay, so let's see if I was able to pull some information from there. Let's say I want to just pull the first 10 lines, which is probably going to be a bunch of copyright stuff. So you do that by going lines and 10, and then we're going to throw that into text, and then do say, and text, and it'll pull those lines out and display that information if it exists. Whoops, I hit the wrong thing. And there you can see it went and got all that information off the web. All right, so cool stuff. And now I want to talk about classes. Now, classes with just like other programming languages, are going to be used to simulate real-world objects by defining those real-world objects' attributes and capabilities, the capabilities of which we're going to call methods. So I'm going to create an animal class, and let's say that you would want to create a private attribute. You're going to say has $, exclamation mark, and name, and there you go. Now you have a private attribute. Let's also say that you would like to have some public ones. Well, you're going to have has, and you would be able to define the data type if you would like to, just like that. And let's go and have height. If you want it to be read and writable, you're going to say is read and writable. You can provide default values if you'd like as well. The next one I'm going to not define, just to show you that you can do that as well. So weight is read and writable equal to, and give it a default value of the same as previous. Build, or the constructor, is going to be called anytime an object of this class is created, and how you create that is you say method and build, and then you're going to put a colon and whatever this is going to be, name. I'm going to put an exclamation mark here saying that this is a required value that must be passed, otherwise we will have problems. And then I'm going to say height, and then I'm going to say weight is also going to be passed to this guy. I can then come in and assign a value to name, just like that. And name is the attribute that was passed inside of it. I can then set it up so if a value was not passed, I will be able to gracefully handle that situation. So we could say something like, if height has a value, then I'm going to store it. Otherwise, I am not. So I'm going to say height is going to be equal to the height value that was passed inside of it. And otherwise, I am going to give height a default value equal to 0 or whatever. So we can do that for the weight as well, just in case somebody didn't go and pass a weight inside of there. And just change this to weight very conveniently. And I think that's probably enough stuff. Now, before I close off this class, let's say I would want to provide access to the name or create a getter for name. I could do so just by going method and name, and then inside of the brackets, I can say name like that. Go and create a couple more. You could make the name mutable also by coming in and saying method name is read and writable, and then go and throw this part down here after that. So there's another thing you can do. Let's go and create something called info, which is going to provide all kinds of information on our objects that we create. So it's going to say return, and if I want to return or refer to the object's name, I just use self. Can't do that because the class is created before the object, so I don't know what the object's name is. So you can use self and it'll just figure it out for you. So you can just go and output all this information: centimeters tall, and self weight is going to be kilograms, and there we go. And then you can also create what are called abstract methods, which are basically subclasses that will be implemented by subclasses. So you can go, let's say that the animal object itself isn't going to make a sound, but we want something in the future to make sounds. You just put 3 exclamation marks inside there and close it off, and that's all you do. All right, so now let's go and actually have this do something. Let's say we want to create an animal. I can go my spot is equal to animal new, creates a new animal object. I can then go and assign values to it. So I'm going to say, whoops, I don't want to put a semicolon there. I want to put a colon there. I can then come in and say name and assign spot to it. This is going to be passed to the constructor. And then I can assign a value for height, let's say 63. And then I can also assign a weight, which is going to be 40. Put a semicolon there at the end just to close that. I can go and get my name value by saying say and spot followed by name. I can go and assign a new name, but if name wasn't marked as read writable, which it isn't, this would throw an error. But so you can go and try and do that thing. So if I went and tried to do that, that's going to throw an error if I don't have name marked as read and writable, which I don't, but I showed you how to do that, so go ahead and do it. I can read and write to our height and weight. So let's say I decide that I want to change these values. I can do that and go and change the weight value as well. Let's just change this to 35, something like that. And then I can go and call that info function just by going spot and info. As long as I didn't make a typing error, you can see that it works. All right, so cool stuff. So there is the beginning of that. Now what I want to do is talk about inheritance. So I have a animal class and I want to inherit from it, which means I want all the methods and attributes from animal to go to a new class called dog. So dog is an animal, and there you go. Now that's all I needed to do. Now I got all those other functions. But I could also come in and add additional things. So let's say sound is, and I want it to be read and writable, and I'm going to go and say that it is wolf by default. I would be able to come in and overwrite methods, so I could say method info and change some things. If I would want to call the superclass version of the function I am currently in, I can say original message is equal to call same, and it's going to call the info function inside of the animal class and return that value to this. And then I can return my new one. So I'm going to say return the original message, and I want to tie these together. I can just do that with a tilde, and then I could say and says and output the sound that this has that the other one doesn't have. So sound. I can also come in and implement that abstract method that we had previously, which was make sound that I defined inside of animal. And what this is going to do is say self name and then follow that up with says and then self sound, and there we go. Now I can go and test all this stuff to make sure it works. So I'm going to say let's call him Doug, is equal to dog and new, and everything that I define inside here is automatically going to be called in the animal constructor. So Doug is going to be passed to the animal constructor, as is the height. And remember, I don't need to define all that stuff, so I'm just going to leave it like that. And I can come in and say that I want to get Doug's name and also Doug's weight. And then I could also call the info function to show you how that updated as well. And there you can see it all worked. All right, so cool stuff. And now I want to talk about roles. Now, a role is going to provide a really neat way to add capabilities to classes or objects. So let's go and create one. So I'm going to create a role, and I'm going to call this area role, and it's going to have some attributes, meaning it's going to basically be this generic area creation thing. So I'm going to go, and it's going to have the option to store a length. It's going to have the option to store a width and the option to store a radius. And they're all read and writable. Then what it can do is create a function. Let's say I call this circle area. And what it's going to do is it's going to return pi, which is a built-in thing inside of Perl 6. And I'm going to go and get whatever is stored in the radius and to the power of 2. So there we went and created that. Otherwise, I could also have an option that has like rectangular area, which is going to return whatever is stored in the length times whatever is stored in the width value. Okay, so it's just like this funky thing that goes and calculates area. So let's go and create a class and inherit from it. So I'll create shape, and I'll say does area role, and it's just going to be this generic thing. Now what I can do is I can just come in and say circle is equal to shape new and define stuff. Make sure you spell shape right. So basically I'm just going to put radius inside of here and say that has a value of 10 and then close that off. And then I can say circle, go and get my area for that. And it's going to be able to do it if I can do stuff right here. Circle A. All right. And if I run that, you can see that I get the output that was expected. All right. So there are roles. And now I want to talk about regular expressions. Now, regular expressions are extremely useful, and they're used for things like searching for specific strings in a large amount of data. They're used to verify strings have the proper format, like emails, telephone numbers, find a string and replace it with another string, which I actually covered covered already, and formatting data in proper forms, and so forth. So I'm going to give you a bunch of examples here. Let's go and create a string. Let's just call it regular string 1, and let's just throw random words inside of it. Now you can go and check for the exact thing inside of it. So I'm going to say regular string 1, and how you do that is 2 tildes in a row, and then you go I'm going to show you a couple different ways of doing this, but I'm going to say that I want to look for specifically word. So this is the most simplistic form of regular expression. I'm asking it for a very specific word, and if it finds it, it's going to give me that result. I could do a little bit more complicated things. For example, I could search for white space inside of a string. I'm just going to copy this and throw it down inside of here, and how I would do that is do a backslash and an S. That's going to handle any white space. So I can say found space, for example, and if I run it, you can see that we were able to find both of those things. And here are some of the most common things you're going to have in regards to escaped characters. You're going to have new lines, which is going to be \n, backslash h is horizontal white space, \t is tab, s like you saw is white space, d is digit, w is going to stand for a letter, number, or underscore, a period is a single character, a plus is going to be 1 or more, a star is going to be 0 or more, and a question mark is going to be 0 or 1. And I'm going to give you examples of a whole bunch of these different guys. So let's go in here and also show that we can work with arrays. So I'm going to say my, and I'll just do NA1 is equal to, and throw in some values. So 1, 2, 3, and 4. I could come in and say if at and search for something. So I could search specifically for 2 if I'd like to do that. And if we were able to find that, I'll say found 2 and output that on the screen, which you can see that I did. We're going to be able to match ranges of values as well. So I'll go create regular expression 1 is equal to, and how you do this is you go rx / and then we're going to use a range. So I'm going to say something like A through D and 1, 2, and 3. Close that off, and then what we'll do is test this regular expression that I have stored inside of here on a whole bunch of different data. So I can do something like say and C E B4 and use the regular expression that I created up here to test that out. Let's go and do it with something else. Could do this with our array that we have up here as well. So just copy that out of there and paste that inside of there and test it, and you can see that it returns those matches that we found. We're also going to be able to get more than just one match, and how we do that is I'm going to store these into an array called matches. So I'm going to say cat, and let's search and get all those. And how we do it is we go M and global, and specifically what I'm looking for is cat, and then I can go say at matches, say plus at matches, and it helps if I have this be matches. Let's go like that. And there you can see, got cat, and whenever we put a plus sign inside of there, it gives you the total number of matches, which is 2. Let's go regular string 2 is going to be equal to, and throw a whole bunch of similar things inside of here. All right, so there's a string with some similar words. And what I'm going to say here is I want to match any single character that's followed by AT at the end of it. So I'm going to go matches 2 is equal to, and regular string 2 is what I'm going to be testing for. And then I'm going to say M global, and if I want to match any single character, I can just go W and then plus, and I want to get the at inside of there, and at matches 2. Output that, and there you can see I got all those things that I was looking for and ignored dog. I could also come in and get only cat, rat, and mat. So we could just do something like my matches 3 is going to be equal to, and use the same regular expression string again that we used before, and M global, because I want to get all these matches. I could put an I inside of there if I wanted to ignore case, and then I'm going to list in that I want CRM, those specific guys, and a plus sign, and then it's going to be followed by at, and then I'm going to close that off. And I forgot to put the brackets inside of here. Brackets like that. Very, very important. And there you can see that I was able to match those as well. And if I want to output this, There you can see I only got cat, rat, and mat, and I ignored case. Now to save some time, I threw a couple strings in here that I want to specifically search for. So now I'm going to once again search for a whole bunch of things inside here, but I'm specifically looking for the parts that have periods in between them. So I'm going to say that I want a single character, and then I want a period. I want another single character, and then I want another period, and a single character and another period. And then after that, close that off, and I'll be able to grab FBI IRS but ignore CIA. Let's go and create another one inside of here. Here I'm going to say that I only want to match 5-digit numbers. So how I can do that is I can go and say that I want digits, and I want them to be 5 in length, and that's going to give me that match right there. Here, what I'm going to do, I can also say that I want to do a range of different values. So let's say that I want digits that are either 3 or 5 in length. I can go and do the same exact thing. So multiply and 3 through a range, and then close that off. Let's come down here, do another one. Here, let's say that I want to check to see if something is a valid telephone number. Again, I'm saying that I want to have 3 digits. So 3 like that. Then I want to backslash. I'm looking for a dash. Again, I'm looking for 3 digits to then be in there for a valid telephone number. I'm looking for another dash, and then I am looking for 4 digits, which will be set up like that. And then I need to close that off, and that like that. See if I got any errors. You can see I matched for FBI, IRS, and 1, 2, 3, 4, 5. Whoops, this didn't match because I need to change that to 4, and I need to change that to 5. And now you can see that I went and was able to match the way that I hoped I could. Let's say then I want to come in here and match for the cats. So I'm going to say that I want to match for 0 or 1 S's. And how you do that is you just go in, put your cat part inside of there, what you want to match against. And then I want to do 0 or 1, and 0 or 1 is a question mark. And there's that. So that's going to do the cat thing. If I change this to 6. Doctors. Let's say I want to match every single one of these potential doctors that I have in here. Again, I'm just going to go in and put DOCTR because that's going to match everything, and make sure that I put my brackets around this properly. Don't need to put a double O inside of there. And then after that, I'm going to have potentially a comma and an S inside of it. Get rid of that extra one there, cause confusion. And the star symbol, and then close that off. And there you can see I match cats and doctors and all the different doctors. Let's go do another one. Change this to 8. Now let's say that I want to capture part of a match. How you can do that is surrounding the part you want with parentheses. So I'm going to say A, and then I'm going to have B and C. And then let's say that I also want to get the D. I was able to get both of those things. Come in again, do some more fancy stuff. Let's say I want to capture when one or another thing matches. So I can come in here and I can do A or C, and then follow that up with a B, and then close that off. Let's say that I would like to come in here and gather all of these cats. Well, I'm going to show you something interesting here. So let's go in, do 10. I'm going to do what you think might work, but it's not going to work. And I'm going to say C followed with and represent our cat. And this is what we call greedy matching. I'm going to also show you what non-greedy matching is going to be like. And you're going to go in here and throw a question mark inside of there and T and close that off. All right, and change this to 10. And you can see right here, whenever I didn't have the question mark on there, that it went and grabbed cat as a whole, because the whole entire thing starts off with a C and ends with a T. So that's a match. So it just grabs that and says good enough. But if I put a question mark inside of there, I'm able to grab cat, all the cats individually. And that's just about everything I'm going to do for now with regular expressions. I have an entire tutorial on regular expressions if you have any interest in that. And finally, I want to talk about grammars. Now, basically, grammars are classes that are going to be used to parse complex text. And I could do an entire tutorial on grammars. I'm just going to give you a simple example so that you completely understand the basics of them. And what I'm going to do here is create a grammar that's going to parse numbers. I'm actually going to do 2 of them. So let's come in and let's just call this number. And the first role is going to be called top. And what we're going to say whenever we're defining this guy, you're going to type in token and top. And what we're going to say here is that our number can contain a negative sign and 1 or more numbers and maybe a decimal place. All right, so I'm going to come in and define this. So I'm going to say that it might contain a negative sign. Then it's going to have 1 or more numbers. And then it might have additional stuff after that. And the additional stuff would be something like a decimal place and 1 or more numbers once again. However, that isn't definite, so I'm going to put a question mark. Okay, so I got that all defined. Now what I'm going to be able to do is cycle through a list of values and see if they are a match for what we just defined. So -456 and 2.35, and let's cycle through those one by one with a little arrow symbol, throw those into a variable called num, and then we will output them. So we will go number, whoops, make sure it's uppercase, number, and parse, and those individual numbers that are inside of it. And if we do, we're going to go like this, and then I made an error. What'd I do? Whoops, I went and didn't make this one uppercase. That's okay, did it? And now you can see that we were able to match every single one of those. Now, however, you are going to be able to create multiple tokens, each with their own role, which is going to make things a lot easier to understand. So let's create another grammar, and let's call this number 2. And the token at the top, called top, is going to get its sum match based off of all of the tokens that follow underneath of it. So what we're going to do is we're going to have something that's going to match for a sign, and I'm keeping this extremely simple. And then we're going to have something else that's going to represent value, and you're going to see the names of those underneath. So then we can come in and we can define all these different things. So token sign, and I could put a plus sign in there or something, but I'm not going to. All right, so that's going to represent the sign, and then we're also going to have number, and that is going to be represented by 1 or more digits, and then I can do a combination of all those, which is going to be value, which is going to go up inside of there. So we can do value, and we have to basically match everything that is going to be done. So we could have just an individual number, or we could have a decimal that is then followed with the number that we defined above, or we could have a number. Actually, now that I'm thinking about this, I should do it in an opposite order, but the tutorial is getting kind of long, so I'll let you do that. All right, so I'll go like that, and I'll give you an example of seeing 2 different things. So we'll go number again, like that, and then another number at the end, and then we can test what we just created. So try doing this for homework. Take this, put it up there, basically flip this and put it in there and see how your results change. And then what I'm going to do is I'm going to go 4, and let's just go and do exactly the same thing again, and we will paste that inside of there, except in this situation I'm going to go and call this number 2 parse, and you're going to see it matches for all of those different values as well. All right, so there you go, guys. That is a 400-page book on Perl 6 all in one video. Hopefully you guys enjoyed it, and like always, please leave your questions and comments below. Otherwise, till next time.